First, prepare the drill bit. Then connect the chuck of the electric drill to the drilling machine to drill holes with the drill bit. Keep the drilling machine perpendicular to the concrete surface. Push the electric drill evenly with force, and continue drilling until the desired depth is reached. Afterwards, insert the diamond grinding head on the grinding machine into the drilled hole. Hold the grinding machine by hand. Make the positioning disc tightly against the concrete surface, and slowly and evenly rotate around the drilled hole. During this process, the positioning disc should always be perpendicular to the drilled hole. When the center rod of the grinding head touches the hole wall, the grinding machine can be stopped, and then the residue inside the hole should be cleaned up. Next, screw the punch into the expansion bolt, and insert the expansion bolt into the expansion spring. Afterwards, insert the expansion spring into the formed hole. Use a hammer to strike the punch, and drive the expansion bolt into the expansion spring cavity. When the limit and face on the punch contacts the expansion spring, the punch can be removed, and the pull rod can be screwed into the expansion spring and tightened. Next, install the detector. First, feed the detector host onto the pull rod. Aligning the pull rod with the piston, place the pressure oil pump in an upper position for ease of operation. Adjust the support legs so that they can be tightly attached to the surface of the concrete. Fit the pinch bolt nut onto the piston, ensuring that the nut is about 2 mm away from the piston. Install the oil pump handle and rotate it counterclockwise to ensure that the oil cylinder is reset. Press the on-off button to turn on the machine. The screen will display a number in the upper right corner, and the real-time pressure value in the lower part of the screen. Press the up button and the screen will display the word peak, indicating that the peak hold function is activated. Tighten the pinch bolt nut again until a number appears on the screen. Press the 0 button to reset the number to 0. Now you can start the actual testing. During the actual testing, you should rotate the oil pump handle clockwise at a continuous and uniform speed, and the speed should be controlled at 0.51 kN per second. You should also hold the instrument and the pressure plate to prevent the instrument from falling and causing damage. Continue to apply pressure until the value on the instrument no longer increases. At this point, the value on the instrument is the pull-out force value, accurate to 1 millisecond kN per second. Press the Save button to store the maximum pull-out force value, and the testing is completed. After the testing is completed, you can disassemble the testing instrument. First, remove the main unit, and then unscrew the pull rod from the expansion spring. After that, insert the rod into the tube. Then screw the rod into the expansion spring, and finally loosen the nut and slowly unscrew the rod from the expansion spring. Measurement points should be installed, first on the side of the concrete pouring. If it is not possible to install measurement points on the side of the concrete pouring, they can be installed on the top surface of the concrete pouring. Before installing measurement points, the surface lattice of the concrete should be removed, and the area where the measurement points will be installed should be polished flat. The installation should avoid joints, honeycombs, and rough areas, and the damaged surface of the later anchoring method should not expose any reinforcing bars. Each component should have 3 evenly distributed measurement points, with a distance of no less than 300 mm between adjacent points. The distance between the measurement points and the edge of the component should be no less than 150 mm. When the difference between the maximum or minimum pull-out force and the middle value is greater than 15% of the middle value, 2 additional measurement points should be added near the minimum pull out force measurement point. The measurement points should be numbered and, if necessary, a schematic diagram of the layout of the measurement points should be drawn. Using a drilling machine to drill holes. During the drilling process, the drill bit should always be kept perpendicular to the surface of the concrete. 3 holes of the same diameter should be drilled continuously, with a diameter of 27 plus or minus 1 mm and a depth of 45 plus or minus 5 mm. To ensure accuracy of the test, after drilling, a blower should be used to remove any remaining dust on the inner wall of the hole, making the whole wall clean and dry. Next, we will begin injecting adhesive into the anchor hole. Take an anchor bolt and make sure its end is covered with a plastic cap. Then screw the anchor bolt into the adhesive positioning disc, making sure that the threaded end of the bolt is flush with the end face of the disc as threaded hole. It is recommended to apply a thin layer of Vaseline or lubricant on the adhesive disc for easy removal of the disc. Afterwards, insert the anchor bolt into the drilled hole, ensuring that the anchor is vertically aligned with the concrete surface and that the pressure funnel is facing upwards. Then, begin injecting the adhesive. The adhesive used for injection should be of grade A. To ensure a uniform mixture of the A and B components, it is recommended to discard the initial small amount of adhesive dispensed from the gun before beginning the actual injection process. The adhesive positioning disc is equipped with an injection hole and a pressure funnel. Slowly and evenly inject the adhesive into the injection hole, allowing any air in the hole to be expelled through the pressure funnel. When the anchor adhesive overflows from the pressure funnel, the liquid level exceeds the upper edge of the whole wall of the drilled hole, indicating that the injection is full. Wipe off any excess adhesive that has overflowed and cover the injection hole with the cap. At this point, the positioning disc is bonded and fixed to the concrete surface, and the injection is complete. After all injection points are completed, wait for the anchor adhesive to cure naturally, which takes about 24 hours. Step 1. Use appropriate tools to tap and remove the adhesive disc, allowing the disc to come off. Then, take off the disc. Afterwards, screw the rod into the anchor bolt, which can be done with the help of a wrench or other tools. Put the reaction support ring on the rod. First, remove the tripod legs from the multifunctional tester. Once disassembled, testing can commence. Then, put the reset testing machine on the rod and make sure the pressure pump is positioned above for easy operation. Finally, attach the wing nut and tighten it to secure. Next, install the pump handle and turn it counterclockwise to ensure that the oil cylinder piston has reset. Step 2. Rotate the pressure gauge to face upwards. Press the on-off button to turn on the device, and the screen will display a number in the upper right corner and the real-time pressure value are in the lower part of the screen. Press the up button and the screen will display the word peak, indicating that the peak hold function has been activated. Rotate and tighten the wing nut again until a number appears on the screen. After that, press the 0 button to reset the number to 0. Now you can start the extraction experiment. Step 3. Rotate the oil pump handle clockwise at a continuous and uniform speed, and the speed should be controlled at 0.51 kN per second. Continue to apply the extraction force. During the pressure process, be sure to hold onto the instrument and the pressure plate to prevent the instrument from falling and causing damage. Continue to apply pressure until the value on the instrument no longer increases, and then the pressure is finished. Next, press the Save button to store the maximum extraction force value. With a precision of 0.51 kN, remove the testing instrument host. We found that the measuring point showed a complete cone-shaped failure state. When one of the following abnormal situations occurs, the false value of the measuring point should be discarded, and a new measuring point should be tested nearby. 1. The failure of the rear anchoring method shows an incomplete cone-shaped failure state. 2. There are significant defects or foreign objects on the cone-shaped failure surface that affect the accuracy of the test. 3. Cracks appear in the concrete outside the reaction support ring. Step 4. Disassemble the testing instrument. First, remove the air pump handle. Then unscrew the pinch nut counterclockwise. Take the testing instrument host of the pull rod, and then remove the reaction support ring. Use a hammer or other tools to knock off the concrete blocks on the anchor bolts to facilitate the removal of the pull rod. Heating the anchoring adhesive with fire can facilitate the removal of the anchoring adhesive and achieve the purpose of reusing the anchor bolts. Click Set to enter password mode, then press Check and the up arrow key to enter the password 1234. Press Set to enter the aerial parameter setting interface. Press the up key to switch. The user can choose the corresponding code according to the size parameters of the test block used. Select the area code used. Press the Save button to save. Long press the Set button to return to the measurement interface. After setting the area parameters, press the Up key on the measurement interface to switch. Note: when the difference between the maximum and minimum values of the three pull-out forces in the component is less than 15% of the intermediate value, the minimum value should be taken as the calculated value of the pull-out force of the component. When two measuring points are added, the two pull-out forces measured should be averaged with the minimum pull-out force, and then compared with the intermediate value of the previous pull-out force. The smaller value should be taken as the calculated value of the pull-out force of the component. After the extraction force calculation value is obtained, use the following formula. The estimated value of the concrete strength of a single component can be converted during sampling inspection. The concrete strength conversion value of each measuring point shall be calculated. The average value and standard deviation of the strength of the test batch of concrete shall be calculated according to the following formula. Afterwards, according to the above values, the estimated value of the strength of the sampled concrete is calculated according to the following formula.